My name is Stephen Olaide Ogunlade, and this is my video submission for 6.2 final project, My Communities Analysis and Presentation of Findings Based on Analysis. Now, to start with, my first community dataset has to do with the New York Basic School Enrollment Dataset, and this contains information about student enrollment in basic school in New York. And then in this dataset, actually, there were a lot of tables. However, I have to drop some of the table in order to linearize it for the purpose of this analysis. And even inside the tables, I have to drop some column also. Now, I was left with only three tables that were used for this analysis entirely, and then in agreement to the requirement of the task. This is the basic educational data system, the enrollment, that has data sets submitted by different schools based on their enrollment on the resumptions of school. And then the next table is the BOCES and the NRC, which contains information relating to basic education system that use a cooperative structure where schools share resources, and also contains indication about the need index level of each district and each school. By need index level, I means in terms of high resources required schools, mid resources required school, and low resources required school. This helps to identify the need level of each of the schools in each of the districts. And then the last table here, demographic factor, has information about ethnicity, race, and gender of students based on their enrollment into each of the schools, based on the enrollment number supplied by the school. And these data sets can be gotten from this link attached hereby. So going into the analysis, I have four questions in this first community. Three questions were supplied by me, while the fourth question was supplied by a colleague who is also a student. The first question is to understand how total K-12 enrollment has changed across schools with different demographic mix over the year. Now, I want us to understand first that there's enrollment figure for K1, K2 up to K12, and even pre-KGs and kindergarten. However, there's a column in the dataset named K12 which contains the summation of all the enrollment from K1 to K12. So in order to linearize the table, I only pick that K12 since it contains the total enrollment already from K1 to K12, and that is what I used for this analysis. And stakeholders that can be interested in this kind of questions are the state education policy planners, the district administrators, because this will help them to understand and compare the enrollment across the New York Basic School with respect to student race and ethnicity, and then to be able to understand the dynamics. Now, how? I will show this demonstration using the SSMS, even though I provide some summary information that can be read here. So looking at the first script from my screen, now when I develop the script, I put it into a view so that such kind of script can easily be referenced in later time. And you can see the script here, firstly creating the view, and then I select the entity ID is the unique identifier for each of the schools or each of the institutions that their data sets are represented in this database. And then I select the year. Typically, there are 3 years represented in this data set: 2022, 2023, and 2024. And then I select their ethnicity or race as available in the data set of demography, and then Hispanic and white. So if I should run this is going to create this view. However, I created the view already, so I can just select the result from the view in order to fill the result. And as you can see it here, you can see year 2023, you can see the K-12 enrollment, and you can see the number of black, number of Hispanic, and number of white. You can see the variation in the demography based on year. And with this number, you can see the trend of increase or decrease based on particular ethnicity or based on particular race. And the entity code stands for each of the schools in this region. So after that has been gotten, the next thing is to go to the second question, which is question number 2, which asks for which counties shows the most gender balanced student population and do they enroll more students overall? It's not only about knowing if there's gender balance. We want to look at what is the total enrollment figure. So, and the stakeholders that can be interested in this is equity and access analysts. And this kind of insight helps them identify counties where gender representation is balanced, because that can help signal fair access to education and inclusive enrollment. So, showing this through SSMS, I will just go to question 2 as I have it here, and this is the script for it. Here, it's only a select statement. I did not convert this to a view. So I'm going to run the script, and you can see it here, that you can see each of the county. You can see the total female, total males. You can see gender gap, which is a subtraction between the male and the female number. And then you can see the total enrollment. So this has the least gender gap. To determine whether it's gender balanced will be based on the parameter set by the policy planners and the government agencies. So if 96 gender gap fit into being called a gender balanced, fine. But this is what this result return for you to see the gender gaps and the total enrollment for each of them. Now going to question 3. Question 3 talks about the need resources schools to identify their capacity or the requirement for resources in that particular school. And district stakeholders interested here can be district administrator, helping them to plan well, helping them to understand district and regions that has high need for educational resources. So, and then this helps them to also serve large population, because definitely you can see, and that can help you plan funding, staffing, and support service appropriately. So we are going to run this to see the K-12 enrollment based on the need index area that has high needs, mid needs, and then that has low needs. So I'll go to the SSMS, and then I will locate my question number 3. Now I created this into a view because typically these are questions that can be referenced almost every time to be able to know how it's going. So once you run this view, the view I've already run it and it's saved. So I will run the select in order to view the result of the view. And then you can see it here. From here now you can see New York City has the highest enrollment, and they has high need resource category, indicating that enrollment is targeted towards urban area compared to the rural district and the urban suburban district. And you can see that that can help planning and can help strategic funding into that particular location. Question 4 is how to compare how the same school enrollment changes each year. And state education policy maker can be interested in this because they will help them to monitor year to year enrollment changes for a particular schools and see the trend in population growth also. So to do this, I will go to the demonstration in SSMS, and then I will run the query. Now it's a question of a particular school. Let's say the particular school of interest is Abbott Hill Elementary School. So I can just select this query and run it this way, and you can see it will return all the enrollment data for this particular school based on each of the year that the data set was entered. However, if you are concerned about all the schools that are in the record, not only a particular school, you can also comment this out, and then you bring out this part of the code, and I will run this, and you can see all the schools names and then the enrollment. You could see even some schools are having zero enrollment as at 2022 for this Bolivar Richburg pre-K program. So this helps you give an insight to the trend in enrollment in each of schools and help you to target your programs and your item appropriately. Now moving to the second data set, this is Kotoso retail data set. It's a data set that is based on retail businesses. And then these are the table of interest under this data set. One of them is the customer table, order rows table, orders table. Orders table has each order that is being made by the customer, each unique order, while orders row contain the details of each unique order in terms of each of the products that were inside that order will now be explicitly listed inside the order rows table. Then we have the product table that has information about the product, the unit cost, and the selling price. And this data set is gotten from this link. Now going to this dataset analysis, 4 questions were gotten out of these two. 3 were from me, why one of the question was from a colleague who is also a student, and the name of the colleague in this case is Zachary Curtis. So now, going by the first question I have to check here is, which product category generates the highest total revenue when combining other details? So the concern is about product that has the highest total revenue, and stakeholders that can be interested in this are sales and marketing manager, and this helps them understand the revenue drivers and help them refine their marketing campaigns, improve their inventory planning, and even identifying opportunity. So going into my SSMS, I will open the script up for the second data set, and then we're going to run the script for the first question. In this case, I created a view for the script also, but then I can leave out the view for now and then run the select component of the view alone. And you can see this is the category. Products that are in the categories of TV and videos actually made the highest total revenue. And this can help you plan your inventory and know the product category, not the product itself in this case, the category that is bringing the highest stream of profit into the organization. So secondly, the second question talks about the stores that generates the highest total revenue and how does their performance compare. Just like Amazon, the data set has sales record for each of the sales outlets on the platform. So with this, you can easily identify top performing stores, diagnose why certain stores outperform others, probably based on the product they sell, and you can replicate these successful strategies across other stores. And the stakeholders that can be interested in this are executive leadership, let's say VP of retail or sales strategy team. Now, in order to demonstrate this, I will go to SSMS and then I will go to script 2 I've written here. Here, the same way I created a view for this particular select statement, but then it has been created already. So I can choose to run only the select component of the view, or I only select from the view directly as I have it here. So you can see here, this store with a particular name, online store, is making the highest revenue, and then followed by Kotozo stores, Kensas, and every other ones according to how it is. So scrolling down to 67, you can see Kotozo store for Saland is making the list of the revenue based on the number of stores in this data set. So question number 3 is to check which product have the largest difference between their selling price and unit cost. Unit cost is what is paid, or the cost of getting the product, while selling price is the cost at which you sell out the product, including your profit margin. So the difference between the unit cost and the selling price help you identify how much profit you've made on that particular product. And the higher they are, the more tendency it indicates the high profit items. So product managers can be interested in this, and this help them to prioritize product development. It can also help them to adjust their pricing strategies too, and also help them to discontinue low margin product, to take it off their inventory. So in order to demonstrate this, I will go to SSMS, and then I will go to question 3, and this is the script I have here, selecting the product and every other information from the other rows and the product. So I will highlight the script and run this, and you can see this is a particular product. This time around is now the product, not the product category. So this is a particular product, and you could notice this product making the highest sale is not even in the category making the highest sale. So you could see this product computer, and this is making the highest sale, and this is the total profit that is being made. This is the total cost. The total cost is the unit cost per one multiplied by the total number of quantities sold, while the total profit, as you can see it here, is the unit cost, the unit price that you sold the product minus the unit cost, then multiply by the quantity sold, as you can see it here. So that returns the total profit. So going to the last question in this section, which is question 4, which helps identify what are the products with highest total quantity sold across all stores. Now, this is very tricky. The product with the largest profit, high profit item, it's possible that it's not the product that you sell the highest quantity. So because when it comes to quantity is another thing entirely. So with that, now this particular question helps you to plan your inventory, help you to plan your retails, and also it helps you to determine how to meet customer demand consistently across all store. So I will run the script for the number 4, question number 4 as we have it here, selecting product name and the sum of the quantity that were sold. And you can see it here. We have this WWI desktop PC 180 with 1,480 units sold. You could see this is the highest product that the quantity is being sold. If we look at the quantity with the highest profit margin, you could see it's very different. This is 1801, and then I will execute this so that we can see it. And you could see this is desktop 2330. You could see they are different. So, but then understanding the one with the highest quantity sold now helps you to plan your inventory, especially on how to meet the demand of your customer. So this brings us to the end of this analysis. Thank you for your time.